Welcome. On this channel, I do unedited, unscripted videos of Linux programming and stuff. Lately, I've been focusing on learning C and kind of been messing around with the build process for that. I haven't really dove too deep into the programming part yet. In previous videos, I had built a makefile and played around a little bit with the Nix build stuff. But since those videos, I have learned of something I guess that people refer to as unified build or unity build in C. And essentially, it is just using the main file to include all of the other C files and then more or less treat it as a single compilation unit. So you are just compiling main.c. And so I'm going to kind of jump in and take a little tour of that since I changed it off camera. I have that I move things over into this project. If I jump into this demo project, this is the way I left it off in the last videos, more or less. And if you look in here, you can see something. I mean, it's my own thing, but it's kind of a traditional idea of a makefile. I think you're collecting together all the different files, eventually doing the compilation here, calling GCC. And if you look at the main file, you know, this is your basic entry point. It includes all the different headers, things like that. And if we go over to this unified hello, which I think I'm going to rename as demo. If we look in here, the build process is quite a bit different. So I think I'll start by showing you, let's go to main.c. And this is really kind of the full idea, since the include files don't do anything other than insert the target file here. The idea is simply to use this to make one unified compilation unit. This main.c just includes everything in the order that it needs to be there. I can do conditional things easy enough, right? So if test is defined, then we actually bring in the Unity C code as well as test.c, which in this case, test.c is what defines the main, right? When we're conditionally compiling for test. On the other hand, if we go back and look, if we're not conditionally compiling for test, then we're just getting source demo as the entry point, which defines C. So I'm getting one main or the other, depending on the conditional compilation. And you'll also notice the thing that's going on here is I have no header files defined here. I'm only including the C files. And even if I go look at these C files, you'll notice that I don't have any header files. As long as I don't have any circular dependencies, this works just fine, because foo completely defines the foo function, right? So anything after that can use the foo function. So as long as there's no circular dependencies, I don't need any header files. If I got in a position where I was writing some kind of circular dependency, my approach would be to break that out into its own C code if appropriate, and simply include that file first, right? So I still don't foresee ever having a circular dependency. If in my code, it certainly could happen in some library that I choose to include. Also, obviously, just like I do conditionals here to get a different main, depending on if I'm testing or not, if I'm doing stuff that supports multiple platforms, I obviously can have conditional compiles here. Or let's say that I'm conditionally compiling on features. Maybe I write a piece of code that can be both a GUI application and a CLI application, and I might have a different main and a few different libraries that might get pulled in under those conditions. But I really like this super. It's so much easier to manage the conditional aspects of the build process in this unified main versus doing it in a makefile. Now, what you end up with then is the makefile is just greatly simplified. In effect, for the most part, all you're doing is saying, hey, compile main, and main is what you need, right? Maybe, like in this case for tests, right, I define test, compile main. So, right, if we take a look at this, first clean. Okay, so you can see the only source file that's actually being listed here is main.c. I mean, it really is as simple as GCC, out bin demo, and then saying, hey, my source file is main.c. And in this case, I do have to include, because this builds with those specific libraries, I obviously have to include those. So that is literally, what did I get wrong? Out is not the way to do that, -o. So that literally is, and that is literally as simple as you can possibly get for probably compiling any C program, right? I specified the target, one source file, and whatever libraries I needed. Really isn't going to get any simpler. And as far as I can see right now, it will handle all future situations that I might need. I can conditionally define whatever compilation structure I want. Okay. That was just a quick little tour of, there is one last component I want to show about this. It is actually faster too. So if I make clean and then just time the make of the default target, time make, you can see we're with GCC, we're all the way down to 0.5 of a second. Whereas if I go back to the old, let's make clean here. So this is the non-unified version of the same code. And if I time make, you can see that we're at 0.7. Not a huge difference. It's a ridiculously small program, but it is actually faster doing it on the unified side. In fact, I can even get it faster because I was playing around the other day, and let's do this. Make clean, and then we'll do time cc equals tiny cc make. And you can see it's all the way down to a 100th of a second. It is, and this build process is so straightforward and simple, I don't really have to worry about like other compilers having issues with it. Make clean, just to show it, it absolutely does work with all the compilers. It even works with, I'm not 100% sure, but I'll try this one. Make clean. This is an old kind of out-of-date compiler. CC equals PCC, which is portable compiler. I think it's designed. I think it's kind of very specifically only to support ANSI C, and I think it's a little out of date. I do think it works though. Nope, it doesn't understand C18. So if I were to build that, but without the C18, it would work, I think. So if I build that and just take out the standard C, right? It does compile. It does complain a little bit, but it actually does compile. Anyway, I really like this unified approach. I honestly can't remember where I first ran across it, and then I started poking around on the web and reading about it. It is not something I had ever run across before, keeping in mind the last time I had written any C code was nearly 30 years ago, 25 plus anyway. And I didn't ever see anybody taking this particular approach back then. Generally, I'm assuming because obviously all of our machines were much lower on memory. That is the offset that you have here, is that you're growing one large C file, and that may have memory impact. Although, in general, we're going to be developing and cross-compiling on machines that have more than enough memory, I think, for any project I would ever conceive of building. I think that you could probably unify a really large C file before this became a problem in the modern world. But that's it. Okay, so I just wanted to explain this in a separate video, so when I move on and everything looks different, there's at least a place to go look and see what happened. I'll see you next time.